the simplifying and multiplying and dividing rational fractions, the pre-assessment. This is the answer key. Here's our first question. We always want to look and make sure. We're going to look at the numerator first. Can we factor it? Is there a greatest common factor? Can we factor it using difference of squares, binomial squares, A times C, factor by grouping? So we can't simplify the numerator, but if we look at the denominator, we have a GCF here. So we can factor out a 7 from both of these terms. We factor it out, and we get the quantity of n minus 7. And so once we have identical binomials, we can cancel them because this binomial is multiplying this number 7. So that cancels, and when we cancel, remember we get 1, not 0. So they don't cancel away, they just cancel to create a 1. So that's why our answer for number 1 will be 1/7. Number 2, we again have a numerator that we can't factor, but the denominator can be factored. We can factor a 7 again. If we factor a 7 out of 7v and a 7 from negative 28, that leaves us with v minus 4, which will cancel with the numerator, and again we get 1/7. Let's look at this problem. This time we can factor the numerator. There's a common factor of 2, and then if we look in the denominator, there's a common factor of 3n. So both terms have a 3n that can be divided into it. And if we factor out the 2, we get n plus 2. If we factor out the 3n, we get n plus 2 also. And those will cancel each other, leaving us with 2/3n. Number 4, this time we have a binomial, and then we have a trinomial in the denominator. The binomial, we look for a greatest common factor, which it does have. It has a factor of 7, so we can factor a 7 out of that. We look at the denominator, and our choices are, is it a binomial square? If it's not, which it isn't, second sign's negative, so we'll do A times C. A being 1, C being negative 21. We'll factor that, and that'll give us v minus 7, v plus 3. And so now we have a v minus 7 in the numerator and the denominator. We'll cancel those. That leaves you with a 7 in the numerator and a v plus 3 in the denominator. Problem number 5. This time we have 2 trinomials. So this is not a binomial square, even though first and third are perfect squares, but again, our second sign is negative, so this is not a binomial square, so we'll do A times C for both the numerator and the denominator. When we factor those, we get x minus 9, x plus 1, and x plus 1 over x plus 1, x plus 2. The x plus 1s will cancel, and that'll leave us with x minus 9 over x plus 2. Number 6. Number 6 is good. We look at the two terms. We can factor out an 8x. Each of them have an 8x. And the denominator, we can factor out a 2. So if we factor out an 8x, that leaves us with x squared minus 1. Factor out a 2, that leaves us with x plus 1. Now, what you might want to make sure, not might, but what you need to make sure is you notice that this is a binomial that can still be factored. This is the difference of squares. So we can break that x squared minus 1 into x plus 1, x minus 1, and now we can start canceling. They both have an x plus 1. And then we can also cancel these coefficients. The 8 and the 2 can be reduced to 4x times the quantity x minus 1. We're not going to simplify this. We're going to leave it factored. It's always important to leave it as factored. I think in the answer key, some of them might not be factored. But in high school, they will ask you to leave it factored. Do not multiply this back out as 4x squared minus 4x. This is the better answer for mathematical and answer purposes. All right. Number 7, you have a binomial that cannot be factored, doesn't have a GCF, it's not the difference of squares. And then we have a denominator that is a trinomial, and we are going to use a times c there. The signs are different, bigger is negative. So we get x minus 7 over x minus 7x plus 2. The x minus 7s will cancel, and we'll leave you with 1 over x plus 2. Number 8 is our first tricky one. We notice in our numerator that it's a binomial and that it's not in standard form. So we would have to rewrite this in standard form. That would give us negative k plus 1. And then we would factor the denominator a times c. Signs are the same, both are negative. So you get negative k plus 1 over k minus 1, k minus 6. Now, we can't cancel these yet. And the other issue, not only was this not in standard form, but we had a first term negative. So whenever we have a first term negative, we have to factor out a negative from the two terms. So if we factor out a negative, we get k minus 1. And now the k minus 1s can cancel. And that leaves us with negative 1 over k minus 6. That negative represents a negative 1, and it's in the numerator, so we would have it in that manner. The answer key might have something a little bit different. There are some that technically another answer you could have is 1 over negative k plus 6. That's not good because, again, our negative, we have a first term negative, and we would rather factor that out. So that negative sign can be in the numerator or denominator. If you put it in the denominator, you have to distribute it out. It's a little bit more of an advanced answer, but I'll put it out there for you. Number 9, we have, now we're multiplying two fractions, and so they've already factored them for us. So what we can do is we can go straight to canceling. So we're going to cancel the b minus 1 and the b minus 1, the b plus 10 and the b plus 10, and that leaves us with 24b over b minus 9. Number 10 also is already factored for us. There are already products all around here. Since they're products, we can start canceling things. M minus 7 in the denominator with the m minus 7 in the numerator, the 2 in the numerator with the 2 in the denominator, and that leaves us with m minus 10 m minus over m minus 3. Number 11 is multiplying two fractions, but they have yet to be factored. So we'll start in each position and move around the fraction to see what we can factor. So the only thing we can factor in this fraction is that top left part. That is actually a binomial square. 3 terms, second sign positive, first and third are perfect squares, and the middle equals 2 times the square root of the first times the square root of the last. So we can make that a binomial square, meaning p plus 4, p plus 4. The denominator is p plus 4, 1 over p minus 7. So these p plus 4s can cancel, and that leaves you with p plus 4 over p plus 7. Number 12, this time we can factor the top right and the bottom right. This is the difference of squares, so they'll produce conjugates, and this is a binomial square, which will produce a binomial that is square or identical. So you're going to get b plus 8 over b plus 5 times difference of squares. These are conjugates, b minus 8, b plus 8. And this is a binomial square, so it'll be identical, b plus 8, b plus 8. So the b plus 8s will cancel. These two b plus 8s will cancel. And then you'll be left with b minus 8, b plus 5. Number 13, we can only factor the top right. Everything else is already factored. So we can factor out a 6 from 6x and 54. That allows us to cancel the x plus 9s, which leaves us with 6 over x plus 8. Number 14, we had a couple of things. We have the top right that we can factor, And then we have to manipulate this one because it's not in standard form. So if we factor out the 7m, we get 7m times the quantity m minus 9. Now we can't cancel these because those are not identical. And now that I've written it in standard form, I notice that my first term is negative, so I have to factor out a -1 from both of these terms. That leaves me with the opposite of the quantity m minus 9. Now I can cancel the m minus 9s. I can also cancel an m in the numerator with one of the m's in the denominator. So that would leave me with 7 over -10m. Don't lose those negatives after you cancel these things. A number of students are finding that they sort of forget this. Now this negative can be in the numerator or the denominator, so an acceptable answer would also be -7 over 10m. Number 15, they've already factored it, but this time we're dividing. So the first thing we have to do is convert the division to multiplication by flipping the right side of the fraction. So whatever is in the denominator needs to go in the numerator. Whatever is in the numerator needs to go in the denominator. Once we do that, we notice that we have an x minus 9 and x minus 9. We have an x minus 8 and an x minus 8. And that leaves us with x plus 7 over 3x. Number 16, again, it starts as a division. They've already been factored. All these numerators and denominators have been factored. So let's just switch the sign and flip the right side. So if we switch and flip, we notice that we have an n plus 3 in the numerator and the denominator. We can cancel an n plus 8 and an n plus 8. And that leaves us with 3n squared over 7. Number 17, now we got to do a couple things. So the first thing is we have to switch the division to multiplication, and we have to flip the reciprocal. We have to take the reciprocal of the right side, and now we notice that we can factor this top right. So if we take out a 9m squared, that leaves us with m plus 4 in the numerator, which can cancel with the m plus 4 in the denominator, and then nothing else cancels here. So our final answer is 9m squared over m minus 8. Number 18, we again want to switch from division to multiplication by flipping the right side. And now we're going to factor the lower left-hand side. That we're going to use a times c. Factors of 80 when subtracted equal 2. Signs are different. Bigger is positive. And that gives us n plus 10, n minus 8. The n minus 8s will cancel. And that leaves us with 4 over n plus 10. Number 19 has a whole lot of stuff going on. So first is we switch from division to multiplication by taking the reciprocal of the right side. Now, I also, as a first step, I rewrote this top left in standard form, and now I have to address the negative, and I have to address the fact that I can factor that trinomial. So if I factor out a negative, it leaves me with r minus 4. If I factors of 72 when subtracted equal 1. Signs are different. Bigger is positive. We get r plus 9, r minus 8. The r minus 8s cancel. The r minus 4s cancel. And that leaves you with the opposite of r plus 9. Now again, the answer key might say negative r minus 9, but we don't like that because that would give us a leading first term negative. So this is the best way to represent the solution. And last but not least, this was a fun one. The first thing we're going to do is we're going to switch from division to multiplication. But the thing that you need to understand and see here is your first term is negative. So when we switch to multiplication and flip the right side, we have to factor out a negative from that first term, taking a negative from all three of the terms. So that'll switch each of the signs. That leaves you with b squared minus 11b plus 30, which we can do a times c. Factors of 30 when added equal negative 11. Signs are the same. Both are negative. And that leaves us with, remember, that negative outside there. This factors to b minus 5, b minus 6. We can cancel the b minus 5s, and that's it. And you'll notice that I get 10 over negative 9b times the quantity b minus 6. You also can take the answer of negative 10 over 9b times b minus 6, but this makes more sense. The negative was in the denominator. It should stay down here. You're most likely going to see this answer 99% of the time. And then here are all the solutions just in case. All right. Good luck tomorrow.